Hi, this is the last part of the review of general chemistry, and we are going to talk about Vesper theory. So, the Vesper theory talks about the bond angles, bond shapes, electron geometry, and the molecular shapes of the different molecules. So, before we come or understand Vesper theory, we should understand the concept of hybridization. So, how does carbon forms sp3 hybridization? So the molecule has the electronic configuration of 2s2 and 2p2. So one of the electron from s orbital is being borrowed by p, getting a promotion, and you form, instead of having four orbitals of hybridized, once upon hybridization, it becomes four sp3 hybridized molecules. So the sp3 hybridized orbitals will look in this way. So it will have the one lobe little bit bigger because now it has the s orbital in it, and which is combined with p orbital. So they're gonna look like this. So after this, that is the reason carbon has a tetrahedral shape, and whenever it forms single bonds, it's going to have 109.5 degrees bond angle. So this is one more good example of how the carbon-carbon single bonds form sp3 hybridization. One thing to remember is the hybridization between carbon and the hydrogen is sp3s. And the carbon and a carbon hybridization is sp3 overlap. And the bond angle is 109. And if you have to represent it in the form of the molecular orbital theory, this is how it's going to look like. Two sp3 carbon-carbons come together in order for the overlap to form the sigma bond. And the antibonding is when you have the opposite ones facing each other. That's why it is antibonding. For double bonds, you'll have usually three orbitals that are hybridized. That's why you have sp2 hybridization. And the sp2 hybridized molecules have a bond angle of 120, and the pi bond is overlapped sideways. So this is like the best way to see the sp2 hybridization. You see they are like overlapped sideways. While the triple bond has the hybridization of just sp. Because in this, only two orbitals are hybridized, not all the three of them. Like here in sp2, three orbitals are hybridized, where two p orbitals and one s orbitals. While in this one, you have one s and one p that get hybridized to form a bond angle of 180, and they overlap again linear shape. So this everything is represented in here in the Vesper theory model. So this is like one of the easiest ways. If you want me to post another video or a quick snapshot of this, please feel free to comment, so I will know to like post one more video or a picture of this Vesper theory, because the sp3 hybridization always has a bond angle of 109, sp2 has a bond angle of 120, and sp has 180. So the sp3 hybridization, depending on is always for the four domains. Four domains means there are four types of four molecules, or it could have one lone pair, three bonds, two lone pair, two bonds, one lone pair, and three bonds. So whenever you have four bonds, it's the molecular shape is tetrahedral and the electron geometry is also tetrahedral. So the one difference between molecular shape is you don't consider the lone pair of electrons on it. But for electron geometry, you do consider the lone pair of electrons. Based on that, the molecular shape is going to be, the electron geometry is tetrahedral for sp3, trigonal planar for sp2, and linear for sp. So the molecular shape and electron geometry is exactly same for sp, But for sp2, the for the one lone pair and two bonds, it's going to be changed to bent shape. So I hope this will be a last quick view of Vesper theory. Thank you.